All right, let's go. So yeah, welcome. I'm Nick from Jellyfish. I've got Luke here with me, and we're going to talk about what we've been learning about what's happening out there in the world with AI transformation. So let's jump in. Just a little bit about us. We're coming from Jellyfish. It's a company that based here in Boston, we help engineering leaders understand how they're using AI tools and the impact that it's having on their software development practices. So I run our research department here, which includes a lot of functions. Most exciting of which is myself and the folks get to look at the data across all of our customers, and we'll be talking about that data, where it comes from, how we get that, and what we're learning from it. How about you, Luke?
Yeah, so I'm Luke. I'm one of the engineering directors actually building Jellyfish, and so I work with our teams that do both infrastructure and data processing, and some of the features and ways that we people explore their data. And so, we're sort of both in the application of how do we use these tools internally, how does our usage and kind of success rates with all this new stuff kind of equate to the larger industry. I go and talk to Nick about this all the time, and I was like, are we normal? Are we different than other folks? Yeah, so excited to be here with folks.
We're normal and different. Luke has
That's right.
graciously graciously agreed to jump in at the last minute. So another Nick on my team who's done a lot of this work with me is
Whole
on
team of
jury.
Nicks.
Yes. So the other Nick is on jury duty, and so Luke, who's one of our other esteemed speakers, knows a lot about this area, agreed to jump in. So we're gonna dive right in. We talk to lots of customers, lots of folks in the industry, and so we have a good sense of the questions that folks are asking. And as Luke said, they're the questions that we're asking ourselves. So, when you're thinking about AI transformation, a place to start is, what does good adoption even look like? How do I know if we're on track to really scaling with these tools? And then once people are adopting, they're building the habits, what sorts of productivity gains should you expect? What's reasonable? What should you see? And we've entered a world where lots of folks are seeing gains here, but what else is going on? What are some of the side effects? You don't just, turn the volume up on one thing and nothing else happens. So what else is going on? What else are we seeing? And one really important question that we hear from lots of folks that we talk to and that we ask ourselves is, what if expectations don't equal reality? And expectations itself is a hard one, because if you're getting them just from, the Twitter X fire hose, that may not be realistic expectations. But I think there's still, your mileage may vary, and what you see in our data here today may not match your lived experience. And what can you do about that? What might be going on? So we're going to go through a lot of things, but just to plug, if you find this data interesting, one place you can go, like we'd love to hear from any of you here at Jellyfish. But one resource that we've just started putting out is we have an AI engineering trends benchmark page. So if you go to this page, you'll see a lot of the data that we've shown here and a lot more. We'll be updating this monthly. I was just working on some exciting new stuff for, based on the February cut of this data. So check it out if you'd like to see more. All right. Well, just an overview. Everything that we're going to talk about today uses data from the Jellyfish platform. And, what we get is, here at Jellyfish, we pull in data from a variety of AI coding tools and autonomous agents. So, IDEs like Copilot and Cursor, Claude Code, we're pulling this from APIs, signals in Git, telemetry, hooks. So we're getting lots of signal about, when and how developers are using these tools. And then we join that data with things that have been part of the Jellyfish platform for a long time, which is a view on, tasks, the type of work that's happening. So things like Linear, Jira, ADO, that talk about, what you built, why you built it, the business value, and then also source control, so we know what actual code is being merged, what's going to deployment, pull requests, those sorts of things. So what that all adds up to is data. What we're going to talk about today is we've been collecting this stuff for well over a year around in the AI impact space. And so we're going to look at data from about 1,000 Jellyfish customers. So we're talking 20 million pull requests and 200,000 developers is going to drive the rest of what we talk about here. So let's jump into some of these questions that hopefully folks have. So, what does good adoption even look like? What are we seeing? So, a basic place to start. The first place to start is access to people even have access to these licenses. Once you have them, um, WAU. It's a simple metric. Are people using these tools? And this is a thing that we track. You can see up and to the right, to nobody's surprise. You see the nice little holiday dip. But as a point of reference, we're at a point as of February where above 60%, I think it's like 63% is the median of, what fraction of engineers in a company are using AI tools. And you can see the percentile ranges there. This is interesting. More interesting, using this once a week is not going to cut it. Hopefully, most of you agree. So a thing that we look at is frequent usage would be the next level beyond that. And there's sort of many levels of sophistication of usage beyond just that. But the impact results we'll talk about today are largely driven by looking at frequent usage. So here it's folks that have been using it 3 days a week or more reliably. And what this stack bar chart shows you is these are now cohorted by companies. So the purple bar, for example, represents companies where 50% or more of their engineers are using it regularly. And so you can see that adds up to almost 60% of companies in our study.
Nick, do you see that as like anecdotally from people I talk to, the difference between I use it when I get stuck and it's replacing Stack Overflow versus like it is the way that I do my code, like an AI first, as opposed to like an AI help assistant or something like that? Do you think there's track to that sort of like work? Are we working in a different way? Does that data kind of support that?
Yeah, I think there's a real mix here. And, this is a high level metric, but when you dig in, you see lots of different behaviors. So you've got folks where there's a mandate that they have to use these things. So they're checking in once a week and checking the box, but maybe it's not helpful for them for lots of reasons. We can talk about some of the reasons why it might not be, all the way up to folks who don't write any code themselves anymore and everything in between. So what you get when you dig into the data is a real mixture of the character of the different types of work. If to do my job, we still have a lot of folks that are in a place where we'll talk about autonomous agents later, but maybe I can have Claude or Copilot Cursor write a lot of the code, but it can't do the infra parts. And there's certain parts of the deployment or certain, bespoke parts of our code base that I know it's going to cause me more headache than not. So you see a real mix, even in some very sophisticated users of this. But you also see a lot of folks that haven't gotten the training or the tools they have access to just aren't set up well yet. And they're trying but not quite succeeding. And then you see people like myself that are using it, for basically everything now.
Cool.
Um, and then the last thing we'll talk about on the adoption side, and this is really exciting and a thing we've been tracking, is autonomous agent activity. And to be clear here, uh, those of you who've been using these tools know there's a whole spectrum between kind of the, in the IDE autocomplete, in the IDE kind of interactive agentic things, Claude Code, which I think most people, and what we see in our data, most people are using in an interactive agentic way. What we're talking about here is when you are able to set an agent off to do a task, you've given it a spec, you've given it a prompt, and it has access to the things it needs, the code base, often data, tests, and it can just crank until it reaches a stopping point and it can open a PR. And so we've been tracking this. This is a much higher bar and a much different way of working, but a thing that you hear a lot about. And you know, if you'd ask me Q3, Q4, is this a thing? On Twitter, it sounds like it's a thing. In our data, you were talking less than, I think, 0.4% of PRs as of like October, November were autonomous. Which this chart here is showing. These are percentile bands cohorted by company of what fraction of their PRs were done by these autonomous agents. And you can see this exponential curve here. So you can see that the median is starting to climb and has reached 1% of PRs by January. But what's really wild is this P90, right? These elite companies, the folks that have been investing a lot in making autonomous agents work for them, they're really starting to take off. So they've gone from 3% to 10% of their PRs are being done by autonomous agents.
Yeah, I hear a lot of people saying, podcasts, whatever, like the tools feel different today. Like if you had to guess how much of this is process maturity, like people have found out how to do it or found a way to feel safe doing it versus I can just ask, like, I just couldn't get this quality of results 6 months ago that I can get now. How much is it just LLMs are better, models are better, tooling's better?
Yeah, I think the low values of this stuff early on, a lot of it I believe was because the capability wasn't there. And you've heard all of the stuff about how there was a phase change, right, with the last group of models, end of last year into this year, and it unlocked a bunch of things. The acceleration of this, what we see and what we hear is that these are big rocks to move, right? To be able to use autonomous agents. There's security barriers, there's sandboxing, data access, and things. It's the IDEs and even Claude Code kind of meets developers where they are, and it's a lower lift in a lot of ways. So this acceleration is largely due to customers that have invested in moving those big rocks, and now it's starting to pay dividends.
Yeah, that makes sense. I was at a AWS event last fall. I think it was September, October. Whole workshop, everybody was talking about human in the loop, and everything was human in the loop this and human in the loop that. I don't think anybody saw this spike coming here the way that it has. Like in that room, nobody was talking about, yeah, about 10% or 5% of their stuff being done with autonomous agent. It was all how do you wire up the right human to the right loop at the right time. So it does feel like it snuck up on us a little.
Yeah, and the standard, what we see is still overwhelmingly. I don't know of any. I don't know if you do, Luke. Any customers that are letting the robots ship code, right? But they're opening the PR, so there's still a person's name. A person owns that code. We're
Yep.
still very much in that standard, and I don't see that changing anytime soon. At least not for our customers or for ourselves here at Jellyfish. But
Yep.
the ability for robots to do this work proactively, often take customer feedback, take things, go off and run with it. And the agent, the changes that we've seen in agent coherence, the ability to stay focused, remain context, manage context on their own, to do a testable thing until they feel they've achieved the goals that you set out for them, and then say, hey, I did what you asked. That's the sort of the thing that's really changed. That's where the capabilities have come in. So you need both the tech that allows that, the access to the test, the access to the data, and you need the agent coherence, the agent capability to actually leverage those things like a developer would.
Yeah, it seems like one of the bleeding edges there might be like agents that self-activate where I'm not writing specs at the beginning and then going out for coffee while it does the work. But hey, we saw a bug. A bug came in and it triggers a response where I get at least a suggested fix, if not a PR or something like that. And getting these things where a human probably needs to oversee it before it goes to prod. I think most people are still there, but you might actually get a PR you didn't ask for or you didn't know was coming. So there's like the triggering from the beginning too. Like how often do we need people there typing a lot of instructions into the system versus it can detect and respond to things? That feels like the people who are really at the high edge of that, they're are happening kind of self triggered or sort of self activating.
Yeah, and there's a lot of context engineering that's involved to do that well. We have some customers who are, have closed that loop of, oh, customer files a bug and that automatically turns into a PR, but there's a lot of context needed for the agent to do the research it needs to do. Um, yeah, let's get to some more stuff. Productivity gains, right? Everyone's interested in this. What productivity gains should I expect? So, productivity is a loaded term. We we think about it a lot here at Jellyfish, all day, every day. We'll talk today about PR throughput. This is an oldie but a goodie. It's still in today's world, in today's SDLC, still largely correlates with units of value, right? I've made a change in the real world, but this could change. This is the thing we're keeping an eye on. Is like, does the PR as an atomic unit of meaningful code start to not make sense anymore? But for now, this is still a thing that we and a lot of our customers care about. So average PRs merge per engineer per week. And related to that, cycle time, here we're measuring it time from first commit to PR merge. We have other ways of measuring this, but to keep it clean, we'll do this for this study. So what you're looking at here, this is data from a study that this is updated data, but it's related to stuff we published last year from a study with OpenAI. and you're looking at what what do changes in PR throughput look like across companies. So this scatter plot, every dot here is a snapshot of a given company on a given week. The x-axis is AI adoption rate. This is how much are engineers using AI from 0% to 100% of the time that they code. And the y-axis is that target metric. In this case, average PRs per engineer. So, higher is generally better. This varies across companies. You can see the variance here. This varies a lot across companies, but the average trend is that more adoption corresponds to more throughput. So you see that trend line, and going from 0 to 100, we're talking about a 2x increase in PR throughput. And you get a similar result if you cohort these companies by adoption bands and compare what is the top adoption rates companies look like to the bottom. Uh, Related cycle time. So now same sort of plot. Every dot is a company snapshot of a given company on a given week, but now the y-axis is median cycle time of every all the code that company merged on that week. And so this is a fun one, Luke. I don't know if you've seen this one before, but it's got these bands. You know what these? Can you tell what these bands are?
No, what are they?
This is like so median cycle time. So the bottom band, horizontal band, is like stuff that takes like less than a day. And then there's a gap because you don't really do stuff in the middle of the night often. Some people do. And then you've got another band of like, this is stuff that I wrote yesterday and then shipped today. And you can imagine
Oh
I've
yeah.
truncated this plot, but there's a big long tail of things that take, sometimes these things take a very long time, right? So cycle times tend to be a very heavy tailed thing. But the average trend here is an average decrease of about 24% in PR cycle times. So we are seeing the work happen faster. So there's more parallelization, but we're also seeing more throughput and faster cycle times on the work.
That's surprising to me because everyone I know is worried about PR reviews and reviewing like if you can generate, 10 times as much code in an hour, that like PRs and reviews and all that other process stuff is where you're going to pay for it, right?
Yeah, and that's where, I mean, I agree, and that's where it gets at a question of value, right? So you know, what we've looked at and what I think, everyone's kind of convinced themselves of is that, these things do help you write code faster, but are you seeing actual business value? And what we see is a lot of customers as they're learning these things, as they're building these muscles, and as they're building the technology, they're pointing it at safe things. So bug backlogs, maybe a lot of these things are prototypes, things that aren't get shipped. We don't have data here on like what's behind a feature flag, what actually made it out in front of a customer. But, from talking to customers, we know like engineers they care about their customers, they're smart, they're safety conscious. They don't want to blow up their businesses, they don't want to lose their jobs. So they're being smart about this, but that often means that you're pointing it at things that are safe or maybe aren't even valuable. Maybe it's just stuff on your bug backlog that didn't really need to be done, right?
You're doing more
So
PRs, but they're ones you wouldn't have even done if you didn't have AI. They would have just sat there
yeah,
as opposed to like the main work. Okay.
so that's where the question for this year is really about everyone's interested in ROI, like what is actual
Mhm.
value? And, just because you can do a thing you couldn't before, is that thing, does that end up, driving more business for your company? Is that, delighting more customers? That's the, billion dollar, I don't know, trillion dollar question. So that's how I square the circle of why you are seeing more code and we're not seeing. We'll talk actually. It's a good segue into some of the side effects. What are the other things that you are or aren't seeing? One thing that we're seeing. So here's another plot, just like the ones we've been showing. Now our metric on the left is average additions per PR. So our PR is getting bigger. So this is how big PRs are on average. Again, every dot here's a snapshot of a company, and there's a trend, there's an upward slope to as you use more AI, you get PRs get about 18% bigger on average. So the code that we're shipping more code and each unit of code is getting a little bigger, right? So that kind of gets at your like review question. Like that sounds like it should stress the system, right?
Right. Especially if people are reading every line of code. Like if we're not
Yeah.
evolving our code reading practice, like where's that time coming from to read those lines?
Yeah. So interestingly, in this one, we also looked at, we looked at a bunch of things, additions and deletions and files changed. This is mostly additions and not deletions. So it's net new code and not like AI is just deciding to rewrite a bunch of existing code for no reason. So it's biased heavily towards new additions versus deletions, and it's there's essentially no meaningful change in the files changed. So this suggests it's more verbose code,
Mhm.
kind of accomplishing the same functionality. It's not like it decided to touch a bunch more files and do a bunch of things it wasn't asked to
Right.
do.
Every PR isn't necessarily 18% more valuable. Like instead of writing three tickets, I wrote one and it's got all the code in it. We're seeing more, some of the coding style changes, things like that.
Well, this gets at the quality question because, I
Yeah.
think that one of the reasons for, bigger code is I know when I use AI, it does a lot of things I wouldn't do, and some of them are good ideas. Like I don't write as much exception handling as as an
Yeah.
AI would. I don't write as
Right.
many comments. So when you think about quality, there's things that AI does that are sometimes diligence that exceed what a typical human developer who's working fast would do. So what about quality? Well, we've looked at a lot of things. We've looked at bug tickets created and resolved. We've looked at PR reverts. We're starting to observe some small impacts here. Last year, we were not seeing anything meaningful in terms of revert rates, but we're seeing it creep up a little bit now in the new year. So about 7 to 11%. So code is being rolled back. So the if you compare the top adopter cohort to the baseline of people using little to no AI,
Mhm.
there's that difference. But one thing that I hear is it's again is like do reverts even make sense as we start to ship code faster? Do you start to fix these things forward? Right? Is it as fast to just apply a new improved version of this thing you messed up versus roll it back, fix it, and then apply another PR? Right?
Right. If I'm auto detecting bugs and I know that my team can move a good amount faster if I could eat a 10% quality drop only as measured in reverts or let's call them follow on changes, let's say
Yeah.
even, but sort of a 10% bug rate that comes up. Like if my observability and my alerting are good and my response to bugs, what about my bug cycle time? If I can make that shorter because AI is putting up PRs for bugs, if I'm
Yeah.
getting the productivity win, I might not mind this. Like, I'm honestly like, yeah, I could live with 10% if we're getting better at turning them around and if they're not taking the site down, right? So, like, not all bugs are the same size. But
Yeah, severity is
as a director of teams, I'm like, I'd probably eat 10%, all things being equal, you know?
as someone who's, loves Claude Code but is deals with the frequent Claude Code outages, right? Like the like
Right.
downtime sucks. It sucks when you're a customer. It sucks when you're disappointing your customers. So,
Yeah.
yeah, the severity of these things are not all equal.
But it's
Um,
good for like the data for, and just to say, like, people reading this and then applying it to their own teams, like, you have to decide and measure. Can you eat 10%? Like maybe you can't because you're building hardware. It's really expensive to fix. Or like contextualizing that to your own teams, right? There's a lot to unpack about what types of quality impact you see and whether the trade-offs are worth it for you.
yeah. Yeah, and this is where it's not a one size fits all thing. You can't just read Twitter and say like, well, those folks are 10xing. Your investors might tell you that, but if
Right.
your own business, it's not all the same. If you're in hardware, if you're in high compliance space, if, people are
Right.
plugged into the medical devices that your software is on, that's a different game. So
Yeah.
we have measured an increase in bugs resolved, which is interesting, and this gets at the thing we were talking about earlier, where we see a lot of folks pointing their AI capabilities at their bug backlogs, where you've got well-scoped tasks kind of waiting there. So we've seen people's bug backlogs. They generally don't go down because bug backlogs never go down, but they are climbing slower for a lot of our customers than they used to as they adopt more AI. So that suggests that um, AI is helping with quality problems, not hurting. At the moment. So there's no smoking gun. I know lots of people are concerned about quality. We're concerned about quality. We don't see anything yet that is like ring the alarm bells, but we're all under immense pressure to deliver more quickly, and the power of these things. We've got foot guns like the likes of which we've never seen in our careers. So we're going to continue to keep an eye on this.
Cool.
And so, last question. What if expectations don't match reality for you? What if, I showed you a bunch of things, or you go to our Jellyfish Trends website, like, this is not my lived experience, right? I am not having a good time. And there's we talked to lots of customers. There's lots of reasons why that could be the case. So I won't get into everything. You and I, Luke, could talk about this for literally hours. We'll talk about one thing that's kind of interesting that came out of the data, because I think it's kind of novel and a bit counterintuitive. So we're going to talk about code architecture, which is a term that I had to make up because I didn't know what to call this, but it's kind of in aggregate how your products and services organized across your repos. So by what I mean by that is it could be like you have a lot of different repos and you have code organized in those way because you have a mono repo strategy versus a poly repo, monolith versus microservices, a federated product strategy, lots of reasons. You're just messy. You grew by acquisitions. There's all sorts of reasons, right? But a metric we'll look at here is active repos per engineer. So, you know, for a given engineer in a given week, how many repos do they push code to at a given time, which is a proxy metric for, how distributed is the code that you have to work with, on a day-to-day, week-to-week basis.
I like this as a
So
metric, just sort of as a team, like as somebody managing teams that have, some complexity in their code as well. You could say for everything I want to accomplish this week, like I want to build this one thing. Well, I've got to add some code to this library and I have to update the library. Then I have to go update the application that uses the library. And then I have to make a change in a different dependency over there. So I'm really making three PRs to ship one feature, right? If my
exactly.
ergonomics are bad about the way my code is spread out, that is a complex code architecture where it is costly even for me as a human to make a change because I know I have to like push buttons on three different systems. That's a close enough proxy for that sort of thing?
That's exactly what we're talking about. And that gets at the context question, right? Like you just explained a bunch of things that live in your head as an engineer, and for a robot to do that job, those things need to be written down, how all of those things relate, of what it actually takes to ship something in that environment you just
Right.
described.
If I just
Uh,
trained it on my one repo, it doesn't actually know about the world that it lives in. It doesn't know how it's consumed in other places, things like that.
Yeah, exactly. And one thing that's nice about this metric too is it's scale independent, by which I mean as companies get bigger, they that as you might expect correlates with the number of repos. Companies twice the size on average, they're gonna have twice as many repositories. When you normalize in this way by engineer, it doesn't correlate with company size at all. So it really tells you about what is it like for an individual engineer, how many repos they work with is not really a function of the company size so much as the company's kind of architectural philosophy. It might vary by division, for a larger company, but it's not correlated with size. So, to put a picture to this is a distribution of that metric across this data set. So, on the left, the x-axis here is that metric of weekly active repositories for engineer. So on the left, you're talking about very centralized architectures. You're working with, 0 to 1 repos per week on average. So smaller and often slower if you're pushing to one, less than one per week. Um, Up to, you see this long tail to the right, called the balanced distributed, highly distributed. So it might be, a world like you described where, if I make a change in one place, I have to do 5 migrations to 5 other repos to accommodate that change and actually ship the feature I want to ship. So these 4 regimes, so we've divided this distribution into quartiles, and we'll talk about these 4 regimes. And so you remember this plot from earlier, the our PR throughput rate and our 2x increase. So if you take all of these companies snapshots for all these different weeks and you now divide them into those quartiles based on the different kind of architecture regimes, you get a thing that looks like this. So we've now got 4 versions of this scatter plot, and if you look at the ones on the top, you still have these trends. Now they look more like 4x. If you look at uh, you know the um, the centralized and the balanced, you see those trends. We're talking like a 4x gain. You get more like the average 2x gain when you look at the sort of lightly distributed. That long tail of highly distributed folks that have to deal with very sprawling code bases, uh, they're essentially getting no effect, and maybe even a slight decline. in terms of AI productivity. So AI is not necessarily helping them at the moment, and I very much interpret this as a context problem, right? Like we hear, I don't know if you've heard this advice, Luke, but I've seen the advice, oh, you should build, if you start a company today, build microservices, right? Small composable things where the AI can just know the whole system, run the whole thing. Um, but if you built microservices 10 years ago and it's gotten messy in the intervening time, or maybe you didn't build this on purpose, but it's just the code base you ended up with for lots of real life reasons,
Sprawled
this
versus
is now a
design
context.
complexity. Yeah.
We've all been there, right? This is a context engineering problem. It's often hard for people, and your best engineers have a lot of, tribal knowledge, things that are, expert, hard-won lessons about everything you have to do and worry about to make things happen in the real world. It's often not written down, or that documentation might be old. So that's what I think folks are dealing with when they're struggling with actually making some of this stuff work in the real world.
Do you think some of this changes with context window growth? Like we've seen in the last few months, like stories of, sessions that used to get lost after 30 minutes of agent use can now run for a week or two. Do you think that we're going to be telling a different story at the end of this year about complex systems?
Yes, and
It's
there's a
hard to
lot
guess.
of
Predict the future, Nick.
well, there's so many countervailing forces here, which is what makes it exciting. So yes, contact windows are getting bigger. So yes, you could just shove more in it, but I mean, you know how big code bases get. Do you really want to shove, the entire code base into it? Like the power of Claude Code has been how good it's gotten in research. So going and finding the stuff that it needs. So
Mhm.
I don't think you're going to get to a world where you're not going to win by making it easy, just like with human developers, making it easy for someone to find on their own the information they need to do their job seems like it's going to continue to win. I think that focus within the context window seems to be getting better, but it's still a challenge. Like you can increase the context window, but if the attention within that context window is sloppy, then that doesn't help you. Um, and then there's cost, right? Like it's it's probably, if you're doing the same sorts of research tasks over and over again, it's going to be cheaper. We haven't seen a ton of price sensitivity yet, but it's coming. People are going to care about how much it costs to do development this way, and in a lot of cases, I expect it'll be cheaper, just like human developers. Like if you make the tools good to use and easy to use, that's going to win out over like, well, it's really expensive to do this, but I pay the cost every single time I develop anything.
Yeah. Let's go. Do you see like, so somebody's going to watch
So,
the, oh, go ahead.
oh yeah, no, go on.
Somebody's going to watch the
No, no,
first half of
we're
the
at the
video.
end. We're at the takeaways.
We're it. We're it.
Yeah,
Um,
yeah,
Someone will watch the first half of this and they will say, well, companies that try harder at AI see more winning. Therefore, everybody on my team, AI harder. Their engineer who watched this all the way to the end is going to go, our code is too complicated. Therefore, we are not inclined to win. And they're going to go, no, it's not going to be good for us. What advice are we giving those folks? Like, is it just simply trying harder? Or are there other things you've seen? And you've done a lot of research that can't fit into this one slide deck, and people
yeah.
should check all that out. Like, what? So maybe one, like, just a note. There's probably other information we can share on that on the forum. But yeah, what advice are we giving those folks? Are they just excluded from the winning?
Yeah, I mean, it's not like, I think it's pretty clear to all of us here. There's no free lunch here, and there's big workflow changes, there's big skill changes, there's big technical rocks to move. I mean, in this example, right? Like if you wanted differences in your code architecture, it could involve moving code around, moving data around, or at the very least building some, like putting some real serious weight behind your context engineering strategy. That stuff isn't free. AI can help with those things, but those are investments. So, what we're seeing is the customers who are winning, like mandates, clear leadership help because they give a sense of urgency and provide direction, but those without any strategy for execution or any resources to actually move these big rocks does not help. Just like any big tech transformation, any big I mean, you've done huge migrations and you've done some huge platform things here at Jellyfish, right? It's very deliberate and requires some real buy-in and investment to do it, to unlock the promised land. But if you don't do it, those can be existential risks from not migrating to the right technology.
Yeah, and I think that that tracks with the stories that we're seeing internally as Jellyfish engineering, but also friends and people that I meet in the industry too, is that moving from a year ago, everybody just try AI, pick a tool, it doesn't matter, and you've got 100 engineers and 100 different tools, and it really was just like try everything at the buffet because you never know, one of them might be magic, to that like more consolidated, more deliberate, like what if everyone just did Claude for a while and we shared skills and we shared knowledge and training rather than, everybody I'm doing something different. So I do think we've seen consolidation of like AI smarter, not just harder, as teams start to consolidate on tools.
Yeah, pick a tool, make it durable, like get some reps, build some muscles.
Right.
Um,
They're also like, right, like build mastery in a tool as opposed to just expect it to do magic for you.
so we're at the we got a few minutes for questions, but the takeaways, AI tools they've showed up in a big way. Autonomous agent use is taking off. If you're not working with autonomous agents, that's a thing that you should be trying to figure out. But we're seeing big productivity changes. Nothing too alarming, some bigger PRs, nothing too alarming on quality yet, but we're keeping an eye on that. And, we talked about some interesting things here in terms of, what actually affects this in the real world. And this code architecture is a good example of kind of where reality happens, especially for companies that have huge existing, technology and code bases. So let's get to Q&A. What do we got?
Questions are quiet so far, so people have some. Feel free to throw them into
Okay.
the chat or into here.
You've
While
also
we're
got a bazillion questions, Luke. You're an inquisitive guy.
I will just ask you questions until nobody else, while I wait for other people to. But if anybody wants to throw them in there, and I'm happy to pass them along here. Um, yeah, so we talked a little bit about like how teams are kind of converging on these sort of things. Do you think that's happening? You think we're going to see data sets in the next 3 to 6 months that sort of show that tool consolidation? Like, do you think adoption numbers will start to converge and tell that story?
Yeah, that is a good question because we've done work in the past. We've seen a lot of growth over 2025. One of the things we track, and I wish I had the chart here, is what fraction of engineers are using one versus two or more versus three or more tools. And we
Mm,
saw huge growth, like a doubling of the fraction of people using multiple tools over 2025. That's kind of saturated, but we're growing our tool base. So depends on what you mean by tool. When you're talking about IDEs, I think we saw a lot of people using multiple IDEs side by side. Some people using Cursor and Copilot side by side. Lots of people using Claude Code in Cursor. And I wouldn't be surprised if you see people picking one, both because they want to build durability in a tool and because companies want to just pick a thing and only pay for one thing.
yeah,
But you've got a lot more, there's a lot more tool when you talk about, well, now we've got to do code review, we've got a security audit, when you've got agents doing
right.
all these different parts of the SDLC, that could end up being a very big kind of tool footprint.
Right. So there's still room to play for in tooling at different parts of the process, not just code gen, where we might see that settle down first, and then there'll be a hundred
Yeah.
review bots and 100 whatever. Okay.
But
Cool.
we are
Cool.
seeing in the data people, churning on some of these things largely because they were trialing multiple ones, and companies are deciding like, we're okay. We did the experimentation. We're just going to pick one. We're not going to keep all these for the whole
Yeah.
engineering org.
Sam is back.
Yes, so one question that came as a direct message to me, so feel free to add them in the chat, but people always love to either Slack me personally, which is good, make sure I'm paying attention. Now, the question was, how do you define agent?
How do we define agent? For this study, what we meant was it was more a workflow definition of, you had an AI coding tool, you gave it a spec, it did the work, and it opened the PR on your behalf. So, I generally don't personally get into a lot of the sort of philosophical hand wringing about what is and isn't an agent. I prefer to think about a whole spectrum from the level of interactivity of the developer to how much are you kind of actively in the loop of guiding this person, almost like pair programming, essentially, is how we think of it, versus are you assigning work and the agent is doing it on your behalf and kind of everything in between. So here at Jellyfish, we take a very much kind of manager type view. We think about engineering teams and engineering workflows. So you think about like, what does it mean to do paired work? What does it mean to delegate work? When does that work well? When does it not well? That's how we really think about agentic things.
Mm. Then the next question is from Daresh and says, can you talk more about the security and governance side of agentic workflows?
Yeah, I mean, those are a really interesting area, and I think that is where, for instance, the autonomous agent thing, when I talked about some of the big rocks, that's a big one. That's a one, we've dealt with ourselves. We hear a lot of customers dealing with, we don't know anybody who's letting robots just push code. I don't know if you know anybody, Luke, in our customer base that is.
I haven't seen
And I think even at the big foundation labs, I don't think they're doing that.
it.
But just the access patterns for these things, right? We've tied so much to human responsibility. A human, you think of SOC 2 compliance, right? A human is on the hook to, define the work, review the work. And so I think there's a lot that needs to be figured out, and that's a barrier for a lot of companies to this agentic work. Is like, for instance, we've had an argument. We always had this practice that another human needs to review your work. In a world where the robot wrote all the code without you doing it, you're kind of like the PM, and we let our PMs say review work that an engineer did. Why can't you review work that an agent did on your behalf? But now there's only one person that's on the hook, right? Is it important to have two humans, or is it important to have a second set of eyes? Or if you have a separate agent review your work, right? If it's a different technology, does that matter? So those are really hard questions, and it's what we see people really struggling to get over the hump on in terms of agent adoption.
There's one question coming in the Q&A box here. Is an agent of agents model realistic, where a supervisory AI agent coordinates and directs the actions of other agents rather than acting independently to help solve the productivity impact being lower for distributed systems? Can
Ooh,
I
that's a
just, as a manager, can I just give my
go
management
go
copy
for
of
it. That's a
Agent City?
spicy one. Why don't you jump in on this one? I bet we don't disagree.
Um, I an agent of agents to me is just an agent that can do lots of things at once. To me, it's like it's either the robots or the humans. I'm still gonna have the thing like Nick said, he was 100% right. Is it okay to have one human reviewer if a robot wrote the code? Like, am I really married to like two human brains, or is it someone who wrote it is less likely to be able to observe it objectively? So a second observer, real or technological, human or not, like a second observer is important because they're not as close in it or something like that. So in my mind, like agent of agents model is a great way to manage lots of agents running, but it can't solve the like, if you believe you need a human reading the code, an agent of agents isn't going to run that code. To me, that's just how many different agents can I delegate to at once? And then can I have some of that delegation happening autonomously? But I don't think it's going to solve the human problem. I think it's just going to solve the agent multitasking problem and help you burn more tokens per hour faster, which I think is great.
I mean, I think we're going to end up in a world where the speed of light for a lot of organizations is going to be roadmap culture and process. There's only, if you can just write code faster, if code goes to zero, we've known for a long time coding is just one part of the SDLC. You take that to zero, all coding is instant. You still need to decide what customers need. You need to test it with customers. You need to enable go to market. They need to sell it. So until those things are faster, which AI can also help with, like those will be the throttles on those things. So that's where I find the agent of agents stuff a little unrealistic. Is I think at a certain point you're just throwing a ton of compute over things that have no business value because nothing else can consume those outputs in an efficient way. You can't accommodate a different roadmap. You can't hire people. You can't hire sales reps faster. You can't enable them faster. Like customers can only buy your product so fast, right? Like there's lots of
Right.
constraints,
Yeah, I don't
before
I
and
don't want every
after.
product having 10 new features every day. Like that would make it harder to use, right? And back to we were talking
Yeah.
about bug data too. Like, oh, agents are doing all these bugs, but they're bugs that we already decided to stick in the backlog and never speak of again because nobody actually cared about them. I don't think we're at the point yet. So like humans made that decision. And it's great, sure. If there's no bugs, like that's fine. But we sort of already agreed that those weren't valuable. And so that gets into the like there is a value decision to be made, and the agents are going to help me bring me more data and more context and even suggest some framings of it. But I think there's still value judgments to happen there.
Amazing. And I think with that, I want to thank you so much, Nicholas. Thank you, Luke. And to answer some of the questions in the chat and that I've got, yes, you will receive the slides. The slides will be shared with you tomorrow. We're also streaming live to YouTube right now. In fact, most people are probably watching me say that, so you're aware. But for those who are here, you'll receive the recording via email as well, or you could go watch it on YouTube right now if you wanna watch back to back, which I think this content was definitely worth it. So huge thanks, Nicholas. Huge thank, Luke. This was awesome.
Thanks for having us.
And
Yeah.
thanks, everybody.
Thank you.
Bye.